Welcome to our class 12. Students, we are going to discuss the subject physics, class 12. So my name is Nikhil sir. Today we are going to discuss the chapter number first, the rotational motion. So in this chapters we are going to discuss the what is meant by rotational motion, moment of inertia and parallel axis theorem. Okay students, we are going to start the chapter number first from the 12th science physics rotational motion topic. We are going to start moment of inertia, parallel axis theorem. These three topics we are going to discuss in this video. So let's start the video. We are going to start the rotational motion. So what is the rotational motion? So which motion is called rotational motions? So students, remember that rotational motion means what? If the system of the particles are perform the circular motion along the some imaginary line, we call it the axis, that is called rotational motion. What I am saying, the system of particles are moving with angular speed, along the imaginary axis. Line, or we call it the axis. It's called what, student? A rotational motion. So one by one we are going to discuss. Okay student. So first of all, system of an particles. So what is system? So what is mean by system? So system means what? Group of particles moving along the circles. Group of particles move along the circumference or move along the centers with angular speed. We have discussed the angular speed in the circular motion with imaginary axis. Say for example, imaginary axis or line. Say for example, students, the motion of the example is, if you draw the motion of this laminar body. If I take this laminar body, okay students, so consider this laminar body. So this body consists of the many numbers of particles over here. So what is the rotational motion? If you move this body rotating about this axis is also called as axis of the rotation. The system of this particle moving. There are suppose system is group of particles moving along this axis. It's called what? Rotational motion. So this is called center. If you call this particle moving along this center, this particle moving along this center, this particle is moving along these centers. So each and every particle has some perform these circular motions. Okay students, each and every particle, suppose this is called a point, this particle P1 with mass M1, this particle called as P2 with mass M2, this particle called M3. So this particle moving along the circumference is called circular motion. Say for example what? If you push the door, so it perform the motion, then hing of the door is called as a axis. If you draw this diagram, Okay students, so here is the hinge of this door. and if you press the if you push this, so it will moving. It's moving what? And each and every particle is moving except some particle over here which are not moving. Each and every particle, system of this, each and every particle, group of this particle on the doors, because door is made up of tiny particles. So each particle is moving in a circle. Okay, but except these points are not moving. So this line joining this point is called axis of rotation for that. Axis of rotation. And this particle perform the which motion, students? Circular motion. Okay. Group of system of collections of particles perform the circular motions along the axis of the rotation. It's called what? Rotational motion. Example of the rotation of the door along the hinge, rotation of the fan, so rotation of the fan. So this again, there is the imaginary axis over here. This fan, tip of that fan or plates, that these two are moving with imaginary axis. Okay, students, this is also example. This is the axis of rotation for the fan. Axis of rotation. This is the example. Okay, motion of the fan. Also example of, we call it the rotational motion. Motion of the particles on the fan perform the rotational motions. Okay, this system is the rotation motion. This is also rotational motion. Okay, these are the rotational motions we are going to discuss. Okay, students. So next we are going to start the moment of inertia. So we are going to start the moment of inertia. So students, moment of inertia is denoted by the letters capital R. Okay, students. So what is the moment of inertia? So moment of inertia nothing but the body has some ability to perform the rotational motion. Any ability. If you take the example, if you take the door, when you apply the external force, what will happen? If we apply the external force to this body, so what will happen? It moving. Okay, it perform the rotational motion. And this is the hinge. And this is the door. And if you apply this force over here, so it will perform the rotational motion like that. This is our hinge, and if you apply the force, it will move, rotate. So moment of inertia nothing but what? Ability of the body to perform the rotational motion. The ability of a body to perform rotational motion. So what about this? So it is simply defined as I, and it is defined as summation I running from 1 to n mi Ri square. Okay, students, and this we can expand this. So what about this? I run from 1 to n. It means my force number is m1 r1 square, m2 r2 square, and so on what? mn rn square. So in this way we are going to discuss, we are going to define the what? Moment of inertia. So students, so m1 r1 square, m2 r2 square, mn rn square. So consider this laminar body. So if you consider this laminar body, so this is the axis of rotation we call, and what about this? This body consists of the n numbers of the particle, collections of n numbers of particle. This body is made up of n numbers of particle. So this is m1, m2. This body is made up of n numbers of particles. Okay, students, and they perform the circular motion. Okay, with along this center point O. This particle perform the circular motion. This perform the circular motion with m1 mass, m2 mass. This particle also perform the circular motion m3 mass. This particle perform this. This also particle perform the circular motion with angular velocity omega. This also perform the circular motion. This body perform along this body rotate about this axis. Okay, this axis of rotation. So in this way we are going to define. Suppose, so how to define that? M1 R1 square. What about M1? M1 is the mass of first particle with radius what? R1. So what about M2 R2 square? What is mean by R2? R2 means what? Particles M2, particles, second particle with mass M2. Okay, student, and what about this? This is a R2. So in this way M1 R1 square, M2 R2 square, and so on what? Mn Rn square. If you have the distribution is a discrete, then we are done. We are going to describe in this way. For what? Distribution is a discrete distribution. But what about continuous distributions? If the particle, if the body made up of numbers of so many particles, so replace this summation into what? For continuous distribution of the particle, for distribution of the particle. So students, for discrete distribution of the particle, we are defined that I is equal to summation I running from 1 to n mi r square. For discrete distributions, we are going to describe as I is equal to summation r square dm. So what about dm? What about r? So where, student, dm means small mass of body. And what about r square m? So r square m is what? Perpendicular distance from the axis. So okay, students, so write down this definition and that notes. Simultaneously, whenever I am taking the topics, so just write down the definition and that, or just whatever that I have taken the notes. So you have to write down it. Okay, so r square means for perpendicular distance. Okay, students, so this is the distribution of the particles. Whenever my body is laminar means what? I have this dish. So this is a laminar body. Laminar means what? Plane body. Okay, students, laminar body means what? Plane. Okay, laminar means what, student? I am considering the laminar body. For distributions, we are taking the I is equal to I summation I running from m to n mi r square for the n numbers of particles over here. And for continuous distribution, r square dm. Dm is what? Just mass of the body. Just mass of the what? If I take this body, so dm nothing but this is called a dm, and this is a r. So dm nothing but dm is a small mass, and r square nothing but what? The perpendicular distance from the axis of the rotation. So perpendicular distance from the axis of rotation, and we consider situation like this. Okay, this is our laminar body and this is our axis of rotation. So what our point over here? Okay, so students, the moment of inertia of a ring about the center of mass or center of mass axis. Okay, and moment of inertia about the moment of inertia about the center of mass center of mass of axis. So what is the students, first of all, what is mean by center of mass and what about ring? So in ring, if you take the ring, okay students, so what is the center of mass axis? We have the formula for standard object, moment of inertia of the standard object. If you have the ring, you can easily find the moment of inertia. But about the center, it means if you want to find out the moment of inertia, so for this is our center. So we have the formula. When my axis of rotation passes through the center of mass, this is our axis of rotation. So center of mass axis means what? Those axes which are perpendicular to the ring and passing through the center. Center of mass means passing through the center. Okay student, those axes which are passing through the center and perpendicular to the laminar body. Consider the ring. So we have the formula for the standard formula, I is equal to mr square. Okay student, center of mass, remember the center of mass also called as the natural axis. Say for example, I have the body that is a disc. Okay, so what is the center of mass for that? So the axis which is passing through that laminar body, passing to center. So this is our center of the disc. We have considered the ring. So ring, disc have the center, own center, and center of mass nothing but those axes which is passing through the line, passing to center of, and perpendicular to the what? Body. Here is this is the perpendicular to the, this is the R. Okay, so this axis must be perpendicular to what? Whole body. Okay. Okay students, try to understand. Center of mass axis also called what? This is the center mass axis, or we call it as a natural axis. Okay, and that should be perpendicular to the whole body. Consider this laminar body, and center of mass axis means nothing but this black marker which is passing through that, which is passing to that center and which is perpendicular. Okay, so we have that formula. So finding that moment of inertia about the center of mass, I is equal to mr square. So moment of inertia about the disc, so this is a disc. Okay students, this is our R. Okay, so moment of inertia I is equal to simply mr square upon 2, where this nothing but capital R over here, and this is also what? Capital R. Now what about this m, where here is what? M is the mass of body and R is what? Radius. But what about the center of mass? This is here also what? M is equal to mass of body and R nothing but what student? Radius of the disc. Okay, so remember the center of mass for disc or whatever that ring is there, solid cylinder is there. So just is the axis passing through the center and which is perpendicular to the laminar body if you consider. Okay, so we are going to start the parallel axis theorem. Okay, so students, we are going to discuss the parallel axis theorem. Okay, if you want to find out the moment of inertia of any axis which is parallel to the principal axis, or we call as a natural axis. This is called a natural axis student, or which is also called as principal axis, or which is also called as center mass axis. Both, this is our laminar body and this is the center of mass axis. Okay students, and this is the axis which is parallel to the principal axis. Both are parallel in this fashion. Okay, So this is our axis, and this is red. This is our principal axis. This is our laminar body, and this is our one of the axis. If you want to find the moment of inertia of this axis when body is rotated about that axis, then we are going to apply the parallel axis theorem. Suppose I have this laminar body, okay students, and if you want to find out the moment of inertia about this axis, and which is parallel to the what? Center mass, this principal axis. This is our principal axis. Remember, this is our principal axis, and this is our what? The axis which is parallel to this principal axis, center mass axis. So if we are going to find out the moment of inertia of this axis, we apply what? Parallel axis theorem. Parallel means parallel axis. Both axes should be parallel. Remember that. Parallel means in this fashion. So both axes should be parallel. So what about find out to that moment of inertia? So simply define what? It is defined as IO is equal to IC plus mh square. This is the formula for the moment of inertia. It means moment of inertia about this axis, IO is equal to what? Students, moment of inertia of this axis, IC plus mass of the body m into square of the distance between this parallel axis, where IO is equal to what? Moment of inertia about what? Any axis parallel to what, student? Parallel to center mass. Okay student, and I see nothing but what? Mi of body about what? Center mass. And I am nothing but what, student? Mass of body. Capital nothing but mass of whole body. Okay, and h nothing but distance between what, student? Two axes. Okay, then we are going to solve this. We are going to prove this. So we will end up on what, student? To prove what? To prove what, student? So to prove that IO is equal to IC plus mh square. Okay students, it means we will end up on what, students? We will end up on IO is equal to IC plus mh square. But student, remember that it means our previous step is what? This IO nothing but what, student? Raise your hand, give me the answer in the comment box. IO nothing but what? What about IO? Moment of inertia about what? This axis. Moment of inertia about this axis, and that should be the what? That should be of the form integration of something into dm, right? But we are considering the P point over here. Okay, here we have to return it. Okay, or here we have to return, consider the point P on the laminar body with mass what? dm mass. Okay, dm is the mass of this body, small mass of that, and point is P. So what is the moment of inertia about that? IO. What about my previous step? Simply r square, integration of what? Distance. What about perpendicular distance over here? This is our perpendicular distance whenever my axis consider this. So what about this? So we will end up on what? Integration of what? Something dm. Something dm क्या आएगा? Raise your hand. That should be our OP square. Okay. What about IC over here? For that point, our distance should be changed. For I have taken this axis. if you take this axis, so what about distance? So give me the answer in the comment box. What about my perpendicular distance? Whenever we are going to discuss the moment of inertia about this axis, IC. So give me the answer in comment box. So we are taking this distance. Okay, students, we are taking this distance. Whenever if you want this moment of inertia, so we have taken this distance as a perpendicular distance. Whenever taking IC, so this is our perpendicular distance. We draw a separate figure for that. This is our point. Okay, this is our COP. Okay. So integration of what IC for IC, or we have to take what CP as a perpendicular distance. So what CP square dm. Now what about n? So we have this small dm. So collection of all dm combined in, so it should be my capital M. Yes or no, student? This is nothing but what mass of whole body, and that should be the, ये सब small dm निकाल के क्या हो जाएगा पूरा बॉडी. ओके, दिस स्मॉल, हे सगळं स्मॉल dm बनून काय होणार तुमच्या पूर्ण बॉडीचा मास बनणार आहे. ओके, सो दिस कॅपिटल M should be written as integration of what dm, because integration and summation both are same. For integration we are using distribution is a continuous, whenever summation we are using distribution is a discrete. There is a continuous distribution, that's why capital M should be my integration dm. So instead of capital we can write what integration dm and h is h square. It means we will end up on what all each and every term is integration, so we can take integration. So previous step is what, student? Previous and previous step क्या आएगा? Previous step, so taking integration, it means previous step क्या आएगा? Integration we are cancelling, right? It means not a cancelling, just for sake of convenience, previous step is of taking integration. So what about this is OP square, this is about CP square plus what H square. But what about H? H is what OC square. It means we will end up on what OP square is equal to CP square plus OC square. Okay, so this is equation number 1. If we are going to start from over here, we will end up on over here, then we are done. So how to get OP square and how to CP square, OC square? So we have the triangle, just apply the Pythagorean to get the answer. So students, we have the triangle OPC. So we want square. LHS should be my square, RS should be my square. So what about my next step? सोचिए इसके बारे में. So give me the reason in the comment box. Which theorem you can apply? So for that, I have extended this line. Okay, students, and draw the perpendicular over here. I am drawing the perpendicular to this side. This point is called as you can take this point as A. Okay, students, my LHS is what OP square. Then we are reaching OP square, CP square. Then taking integration, we will end up on this. So my OP square you want. So apply the Pythagorean theorem. For which triangle we have to apply the Pythagorean? So give the answer in the comment box. So we want OP square. So I have taken which triangle? Smaller triangle I have taken. I have taken this type of triangle. I have taken what? Triangle 1. This smaller triangle, triangle 1. I have taken. So what is triangle 1? In triangle OPA, angle OAP is a 90 degree. So give me the reason by using Pythagoras theorem. What we get, because we will end up on OP square. So we will end up on OP square. It means we start from the triangle 1, because we will end up on OP square. So what? Pythagoras theorem. So give me the answer in the comment box. OP square is equal to what? OA square plus AP square. But what about this? Here we want what? CP square. Here we want AC square. What about here? AP. So again we have to apply what? Theorem. So here is what, student? Here we want CP, OC, and here is AP. Here is OA. Okay, OA plus AP square. But here is what? OA, student. Okay. So what about this? This line is a what? Collinear is there. Yes or no, student? OCA. These are collinear. So we can apply what? Betweenness. So what about this? For betweenness, what about this? So give us equation number first. This is third. Here we get second. So our betweenness is what? OA is equal to what, student? Give me the answer in the comment box. OA is equal to OC plus OA. OC plus, so CP is equal to OC plus OA. Okay, students? But we want what? We will end up on what? CP. So put that value over here. So give us equation number second. Okay. So next we get the CP, we get the OP. What about OC? How to get OC? OC. So here we got what? C. It is not CP, CA. Okay. So we want what? OA. So what about OA we get? How to get OA? Just shifting that side. So what? OA is equal to OC minus AC or CA. Okay. So give the equation number second. OA is equal to OC. I have kept over here. OC. It should be AC minus OC. Okay. AC minus OC. So this give an equation number second. So we get the OA, put over here. What about AP? How to get AP? Again same technique. I have taken this bigger triangle too. Okay. So in triangle, what? A or in triangle PAC. Okay. PAC is a 90 degree. So by applying the what? Pythagorean theorem to get the this value. So what to get Pythagorean theorem? For triangle PAC, this is our PC is a 90 degree. So PC square. What about this? AC square plus AP square. Okay. So students, PC square is equal to, we will end up on AP square is equal to CP square plus OC square. This has give equation number third. So we get the OP square. Okay. So from equation first, so we get the, we will start with OP square, OA square plus AP square. So we have the OA value, put over here. So what is OA? From equation second, AC minus OC. Now what about AP? From equation, so from equation third, AP can be written as what? CP square plus CP square minus AC square. So from here we can read from equation second and third, we can write out this. Okay, students, and here is what? OP square, and OP square is equal to what? If you apply this formula, so then we get is equal to OP is equal to CP square, OC square. You can solve this. Okay, so we get the, we can apply A minus B. We have formula for A minus B. A minus B whole square, we have formula A square minus 2AB plus B square. We apply that formula over here. So what? OP square to AC OC plus OC square CP square and OC square. So what is cancelled? Which one is cancelled? Raise your student in comment box. This should be is cancelled. So we will end up on CP square. We will end up on OP square, and we will end up on what? CP. And this value is very negligible. Okay, students. So this can be removed. So remaining? So remaining in LHS OP square. What about RHS OC square? What about RHS CP square? So then we are done. Okay, student. In this way we can solve the parallel axis theorem. We can prove. Okay. You can write down this, and in next lecture video we are going to discuss the perpendicular axis theorem. Thank you for watching this video. Have a nice day.